Hello everyone, today we're looking at estimating area, and in particular area of shapes that aren't rectilinear, aren't neatly fitting onto square grids. And to illustrate that, I want you to think about this one. Which has a greater area, your footprint or your handprint, and how could you prove it? I want you to think about this, but also, if possible, get a hold of your hand and your foot and draw them around a piece of paper and see if you can think which one is bigger and how do you know? Now, there's a couple ways to look at this. First one is to know that area is how much surface an object takes up. So you could compare one by putting one on top of the other to say which takes up more surface. And this could work well, but certainly when I do it, maybe you'll find the same. My hand is wider, even though my foot is longer, so it's not that easy to do. So maybe I could put them both on some squared paper if I had squared paper. Of course, you might not have it at home. I'm going to link you to a digital tool you can use to replicate square paper, and then say whichever takes up the most squares has the largest area. But then maybe it doesn't cover all the whole squares. If I look at my hand, I look at my foot, they're not very blocky. It's not like Minecraft. So I think I would have to count the squares and the parts of squares. And to do that, let's have a look at an example. Not with hands and feet, but thinking about some others. So can you tell me the area of this shape here? Well, no, not at the moment. I don't have any measurements. But what about this one here? Now it's on a grid. I can see this is 1, 2, 3, 4, 5, 6 across, and it's a square. So 1, 2, 3, 4, 5, 6 down. And I can see that actually I could even draw on where the grid lines are going to be underneath it. And of course, probably people who are familiar with this will already know, we're going to end up with 6 lots of 6. And that would be 36 squares. And if you use the squares is 1 centimeter squared, then it would be 36 centimeters squared. Not the best lines, but you get the idea. What about, though, irregular shapes? Remember them, like with the hand and foot? Well, here are our strategies. We're going to count the whole squares and look for part squares to put them together. And then this is another one we can do. So if you've got something like a circle here, there's the ones in the middle, which are all fine. But then you've got ones that are like here, this one. This is not really a whole square. Same thing with 3, we're kind of missing bits. But then we've got these extra bits at the bottom, so it kind of balances out. So you can see what they've done there is they said this is roughly 12 in here, with 2 extras on the side here. And I think that's a good way of doing it. If you think that these are about, maybe you put these together, you get 1 extra. So about 14. And the same idea here with the pentagon. Remember, penta means 5, and this has got 1, 2, 3, 4, 5 sides. Here they've done something slightly different. Do you see how at the top here, in the middle, there's all these like 9 squares, which is absolutely fine. But then at the top here and down the bottom, they've done this thing where you say, okay, maybe if I put this and this together, and this together, or even think about this, and that corner, that's about 2 whole squares together. And same thing down here. And then up the top here, you look at this one, which is maybe, call it half a square, and then these 2 quarters of a square. Put them together, you get that 1 extra. So you can estimate this is about 17. So this is one way to do it. Now, here are 2 people talking with the conversation cartoon. The red person says shape B has the largest area because it contains the most whole squares. I can see 27 whole squares in the shape, but the blue person says you can't see all the squares properly. You can still work out the area in shapes, shape A and shape B because it's like an array, and you can use your multiplication facts. Is that right? Well, here rectangle B does have more squares. Is it actually bigger though? Well, no, because the squares themselves are smaller. If they were the same size, you could say they do have more squares. If you want to count squares, though, using the array is a good idea. Like with rectangle A, you say 1, 2, 3, 4, 5. 5, 3 rows of it. 3 lots of 5 is 15. Let's write that down here. 15 squares. Rectangle B, although smaller, we've got 1, 2, 3, 4, 5, 6, 7 along here, and along top 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 70 squares. And what about C? Well, C is actually a lot like A, isn't it? It's got 3 rows. It's just diagonal. And then across top 1, 2, 3, 4, 5, 6, 7, 8. So we've got 3 times 8. That's 24 squares. Very interesting. Okay. What about the area of these shapes? And this is where I'm going to want you to pause the video and try this yourself. You may want to use the geoboard tool to try and create some of these shapes. We'll see how close you can get. What do we think? Well, if you pause the video and come back to us, then we can have a look at some of this. The first thing I would do actually with this triangle is say that the triangle is kind of like two triangles split in half. So if we can do one, we can just double it. So what I'm going to do is I'm going to shade in the whole square. So we've got 1, 2, 3. That's absolutely fine. Then I think if we put some halves together, perhaps, I reckon, what if we say we got like this bit here, that could be one more, and then perhaps here that can be one more, and then with this bit down the end, with this on top. Interesting. So then we'd have 1, 2, 3, 4 here, 5, and put these together, say 6. So about 12, I reckon. Maybe 11. Maybe 11. What about this one? This one's really hard. This is a semicircle, half a circle. So with this one, we've got, say, whole ones 1, 2, 3, 4, 5, 6, and maybe these together can fill up the corners out here. Maybe do that in a different color. Cover up that. I think about 6.5. Let's say about 6. I'm going to say 0.5. 0.5 is just decimal way of saying half. This one we said was about 12. This one down here, oh, now this one is really interesting, because what we've got here is we've got a square, but it's rotated. And if I draw a square, it's going to be like this. Bring that over here, and I just rotate it. Oh, what do we notice? Look at that. That square is what we've got shape-wise, isn't it? And then if I just move it over here, you can see it on the grid. I'm going to have to overlap something, I think. And now you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9. A good thing to do is to think about, can you rotate a shape? Can you spin it around to see? Similar idea here. What have we got with this shape, with the rectangle that's on its side? Well, if I try and draw a similar rectangle, and we may have to change the size of it, we'll see. For now, I'm just going to draw this one, and we're going to see, whoopsie daisy. You just lock that. There we go. So I can move this. And now if I rotate this one, oh, I think I might have it. I think I might have it. Oh, it could be a little bit big. Let's see, that is a bit big. So let's just change that size there. Oh, I think that's pretty good. So now I've got my shape. And if I rotate it back like this, oh, now we can start to see what size it is. That is 1, 2, 3, 4, 5. That's 2 lots of 5. That means it's 10. So I can say that down here, this one was 9, and this one was 10. Did you do it that way, or did you try it a different way? So here's something I'm going to want you to do. There's a few things I'm going to change here, but I'm changing them live because I want you to see how we do it in class for the people who are in school, and the way we wouldn't. So I want you to find these objects which cover an area, and to find ones that are smaller than 1 centimeter square. What I would like you to do is to make a thing that you can use to check it. So find something and measure it, like find a piece of paper or something like that, fold it up and measure it so it is 1 centimeter this way and 1 centimeter this way, and that will give you 1 centimeter squared. Then using that, you can try and find some things that are smaller than 1 centimeter, that are between 1 centimeter and 10 centimeters squared, and greater than 1 meter cubed. With 1 meter cubed, you've got to think it's got to be 1 meter on one side and 1 meter on the other side. Or you can have things like 2 meters and half a meter. So long as when they're multiplied together, they make 1 meter. Remember, a meter is quite big, so you're probably looking for things that are quite large in the house, maybe outside. If we were in class, we'd be using meter rulers to measure this. With this one, you might not have a math book to hand, so if you think you haven't got a math book, I'd like to find a different book, and make sure you send me a picture so I know. This one you should be able to do. You might want to use a cup or something if you don't have a pot at home. And then for this one at the end, what area do you estimate is covered by? I'm going to say your table. Imagine a dining room table, because I presume not all of you are going to have desks. If you've got a desk, use your desk. The playground. Could do the playground, maybe say the playground at the park, and a pencil case. I know not everyone has a pencil case, so if you don't have a pencil case, I would like you to say something like a container. For example, a Tupperware container. You might have one in the kitchen. See what you can do, or perhaps a plate. Give that a go, and let me know how you get on. I'm looking for someone to have the most interesting thing to measure, so surprise me. Good luck.